So, those of you who came to the, how many of you came to the hackathon on this weekend? 4.5, 5.5. What did you think? Good? Would you recommend it?
No, sir.
Yes? We'd recommend it. So the rest of the class missed out. They should have come to that thing.
I had no choice.
So there was some announcements on Slack already for when the next hackathon is, as well as a plug for the Hackathon Club. I encourage you to get involved in both of those things. Really good learning experience, and I can pretty much, let me see if there's an exception. I think every year, not that this should be the only determining factor, but the 5 graduates who have the highest paying jobs were all heavily involved in hackathons, who graduate each year. So I think it does set you apart, not just because you've thrown on a resume that you've been in hackathons, but your skill level disproportionately increases compared to just going to class alone. All right, so homework for today was display reverse.
Yep.
All right, so let's look at that a couple different ways. And we'll come back to our binary to decimal stuff here in a bit. All right, so in fact, let me just dump this for a moment. So we're defining display reverse, and this guy was taking in what, a list?
Yes.
Okay, I'll call the parameter a list. All right, so now before I do anything else, I just want to reinforce something based on a couple of questions that I had via Slack over the weekend. So here's a function called display reverse that takes in a parameter that I have named a list. Inside of here, we have access to that variable as a list. So if I come down here and I call, I say A is equal to the list cat, dog, elephant, something like that. And I try to print out A in there, for example. I call display reverse, passing it A. This gives me a result on this parameter. If you remember before, I mentioned that we're going to be talking about, so this is kind of a misleading example. We're going to have something called main, where we'll have something down here where like if underscore underscore name is equal to, I think it's main like that. I think I'm still writing that incorrectly, but let's just roll with it for a second. In most languages, this would have given me an error. It would have said, I've never heard of a variable called A. Right now, we're writing all of our stuff inside of one giant bucket. Okay. Eventually, we're going to be separating stuff into classes, so they'll be in different files or at least into a different organization. And then we'll also dictate when our program begins and ends. In fact, here, let me just quickly just look that up real quick so I can just give you that syntax now. Oh, it's underscore underscore main. So if it still kicks I need to get it outside of this scope. Let's just roll with it. I would need to get it outside of this file to break the scope rules. We have something called scope in all programming. scope says, where is a variable accessible? All right. So I'm going to make a comment here saying all variables resolve to their most local definition. All right. Now let me actually give you an example in a different language for a moment. I think that'll be helpful. All right, so let's say that I'm here. I'm just going to call this guy test.java. Just make it roughly equivalent to what we have here. All right, so if I have so this is something that's I'm doing inside of the Java programming language. So you saw me a few minutes ago try to create something that looked like if underscore underscore name underscore underscore is equal to underscore underscore main. So this is actually a Python equivalent of this guy, but because Python's an interpreted language, some of its scoping rules work a little differently, how variables get stored. But let me show you kind of a structured programming way of this that hopefully reinforces this idea. So if up here, I go ahead and I just say, well, here, this will be good enough, even though it won't give us the output that we want. It'll give us the error that I'm looking for. All right, so I'm going to go ahead and I'm going to create a string array called A, and this guy is going to be equal to cat, dog, elephant. All right, and then I'm going to call, here I'm going to make this guy static so this part's legal. I'm going to go, yay. So then I'm going to go ahead and I'm going to call display reverse, passing it A as a parameter. Now, if I go to compile this, so this is just like in Python, I've created a list called A, filled up with cat, dog, and elephant. Then I'm calling upon a function that I wrote somewhere else in my program, passing it A as a parameter. Inside of that function, I'm going to try to print out a variable called A. So I'm going to go ahead and save this. That's in my downloads folder. All right, so I have a bunch of errors. Let me see what those can't all be. Oh, public class. I think when I put static in there, I broke that. All right, there's my one error. All right, so inside here it's saying error, cannot find symbol. It doesn't know about a variable here called A. Inside of this little world right here, a new variable scope exists. So that means variables can come and go with this guy right here. So inside of this scope, I have a local variable called a list. And that's the only variable that's being defined in there. Yet I'm trying to print out something called A. I know I've defined this variable A down here, somewhere else in my program, but it's not accessible in here. It doesn't have value in here. All right, I lose the, well, which is a good thing in Java. I lose the purpose of it, that Python gives me access to that because of the way we're putting all of our Python stuff in a single file right now. But, you know, punchline is that when I want to print something in here, I should work with the things that I have access to. So if I just change this to a list, now at the very least it's going to compile. It's actually going to give me a weird memory addressy looking thing if I run it. So there's weird memory addressy thing instead of the list. That's fine. I'm not going to go into that right now. All right. But you see that a language like Java, a compiled language, a strongly typed language will give us an error here saying, look, you're trying to use a variable that I don't know about. Fine, you defined that variable someplace else in your program, and that's all fine and dandy. Wouldn't we like to be able to create variables that have different values, maybe the same name in different parts of our program? That would maybe make some sense. And the fact that I wrote display reverse to take in a list kind of indicates that I'd like to call this guy multiple times over and over and over again, passing him potentially different inputs each time. All right, so if in here right now, I'm never using the input that was passed to this guy. Okay, so if I say, there, 1, 2, 3, just to make it simple, then I have another display reverse, and I pass this guy 4, 5, 6. So I'm calling the same function multiple times, passing it different inputs. In this example, that input comes in and is stored inside of that local variable A list. And then I can use it inside of here as A list. In this example, this list right here comes in and gets stored inside of this variable A list. Then inside of display reversed, I'm using that value. Now, if I run this program right now, notice I get cat, dog, elephant both times, because I'm printing out the value of A, which I only defined one time in my program out here. I'm telling you that most structured programming languages, because we're writing this a little funny, would not allow you to access this variable inside of here. The fact that it's allowing us to do it in this case is kind of a sacrifice we're making for putting everything inside of one file. The structure we're writing our programs right now to keep it simple. But at the very least, we can look at this and say, we're kind of defeating the purpose of writing a function that takes a parameter if we're not going to use that parameter for something. If I'm only looking at my world through that lens right there, I have this variable called A, and I don't know where it comes from. If I were to type print B in there, I get an error that says I've never heard of B. That's the error we should probably imagine is happening anyways. Just because I defined a variable out here, I mean, maybe I don't even define a variable out here. Maybe I just pass my list to it directly. Now all of a sudden that A is a problem. That make sense? Just because I temporarily stored it someplace else doesn't mean that that variable was intended to be used in a module somewhere else in my program. The purpose of a function, just like our last assignment was to write, well, the last assignment was the circle, area of a circle function. The idea is if we're calling area of circle 20 times, we're probably passing it different radiuses, or radii. It's one of those two. All right. The idea is we want it to be general purpose and give us the area of any circle for whose radius I pass it, right? In this case, I don't want to have this thing set up for me to pass it a whole bunch of different lists and have it always print out the same list. Does that make sense? I want it to operate on whatever the parameter I passed in is. So if I print out a list here, this first call to it, a list, will be equal to cat, dog, elephant. The second call, a list was equal to 456. If I go ahead and I store my cat, dog, elephant in a variable, which is fine, there's nothing illegal about storing it in a variable, and then I pass that variable here. Bring up my slides. All variables resolve to their most local definition. So this value A, this variable A, is going to resolve to its most local definition, which is this guy right here. So writing A here is equivalent to just writing this, but it allows me to deal with it generically where it will resolve to its value. All right, but we still see that if I'm printing out a list in here, the first time I call display reverse, a list will be the contents of A, which is cat, dog, elephant. The second time I call display reverse, the contents will be that list, 456. Does that make sense? So when we take in parameters to a function, these local variables are how we refer to those inputs. Pretend like you don't have access to these external variables, even though right now the results indicate that you do. Questions about that? All right, so for display reverse, I know some of you did this. You just used the, I think it's just a reverse function, right? It's list reverse, so it's a list dot reverse. So you used a function, I think the book introduces the reverse function somewhere in there. Okay, so some of you wrote it this way. It wasn't my intent, but this is fine. But we're going to write it the other way. So a list has several functions. Last time we talked about, I think a couple times ago, we talked about length and things like that. Some of the functions that we can have operate on lists. Well, lists themselves or collections themselves have a function called reverse that belongs to them. So when this list asks his reverse function to reverse himself, it permanently changes that list. And let me actually prove that to you. I'm going to go ahead and print out A here. We see that A was actually permanently reversed. All right, I'll talk about that here in a second. All right, so I'm asking this list to reverse itself, which does have a permanent impact on the list. And then I'm printing out the reversed list. That makes sense? So that's using a power tool already built into the language that knows how to reverse collections. That's fine. You can do that. I would say this would be something that you should do when you're a seasoned programmer and you need to reverse something real quick and you're already very comfortable writing loops that walk backwards and that kind of stuff. But right now, these assignments are called drill assignments, right? So chances are I'm kind of wanting you to solve them in terms of the things we're covering in class. Remember I mentioned that anything I'm going to be testing you over, I'll cover in class, even though I realize the book introduces a much broader set of tools to you. I won't mark stuff off. Certainly I won't mark stuff off for you using tools from the book unless I specifically prohibit it ahead of the assignment. But my encouragement to you would be to try to solve things in a similar manner to how we're doing it in class. Because that's my intent, to drill you on those skills that are going to ultimately build you up to being a better programmer. All right, this doesn't help you become a better programmer by being able to call somebody else's function that magically reverses it somehow. Does that make sense? All right. Now, the reason, so I'm telling you that this line right here permanently changes a list. All right, it permanently changes a list. So that when I print a list in the very next line, I notice that a list is now the reverse of what it used to be. Okay, does that make sense? So everybody's cool with what it does in here. Now, what we're actually interested in, though, is why did this have side effect on A? And what I mean is when I printed out A later in my program, I noticed that A was also permanently changed. All right, so let's draw a couple pictures to understand what that means. And I think this will help with the variable, how variables generally work in languages as well. All right, so I've created a list. All right, I've created a list in memory. So variables are how we remember things, right? And I've defined a variable named A that we say points to that guy. All right, so let me just give a quick slide before this. Let's call this variable passing. Variables are passed to functions in two different ways. Passed by value, passed by reference, or sometimes called by address. All right, so let me quickly show you a pass by value example. I'll just write another quick function here. Def do something, and this guy will take in a variable called C. I'll say C is equal to 7, and then I'll print out C. All right. Down here, I'll go ahead and I'll have a variable called R is equal to 2. I'll call do something, passing it R, and then I'll also print out R. By our previous example where we saw A permanently change, how come we didn't see this guy permanently change? Could I prove whether or not he permanently changed? What if I wanted to print him out later on? How do I print the 4, 5, 6 out down here?
Well, it's not stored in a variable.
Yeah, I never put it in a variable, so I can't use it again, right? So this guy would be a list literal. I passed it in here. I promised that as far as this function went, he was stored inside of a variable called a list, and him being reversed was permanent. But as soon as we exited this, I didn't have anybody else point to this guy, and you'll see this in an example in a second. So once I called A, I created A here, and we saw in our picture here that one thing points to that list. Make sense? Then I call display reverse, passing A into it. So A comes into display reverse, and now I have a variable called A list, which also points to that guy. So I have a second variable now called A list. That is not a copy of it. He's pointing to the same place in memory where I was remembering my list before. So when I made a change to A list, which caused this guy to be reversed, just magically pretend like it reversed here. When I exited that function and this variable disappeared, A still pointed to the reverse version of that list. Any changes I made to the list, A still pointed to. Does that make sense? As opposed to, let's just see the result here. I'm going to create a variable called R, set it equal to 2. This guy's not a list, he's a number. All right. I'm going to pass the value of R, which will resolve to its most local definition, which is 2. I'm going to passing a 2 in to do something. So it's going to be stored in this variable called C. I'm going to immediately change its value to 7. And then I'm going to print out the value of C, which should print out a 7. The question is what will print out here when I print out R after that function is done. Will it be the changed value of a 7, or will it be the original value of a 2? Any guesses? Think it'll be a 2? There's my 2. Why is this? Let's draw a picture on this guy. Here, we'll put it on the same thing. So lists, we'll just put a fact up here. We'll say lists are passed by reference or passed by address. I'll use those interchangeably, so I'll just put them both on there. Let me shorten up this my pointers. Give myself some space. Whereas I have a variable named R that I set equal to 2. And then I passed that guy to a function, right? And that function had a variable inside of it called C. He got a copy of that value. Numbers and other primitive types are passed by value. So when I passed R into my function, it was handed to C, but a copy was given to C. So I passed in R here, boiled down to 2. So the value of R is 2, as opposed to the value of A. We see the value of A as being this list, but the value of A actually is the memory address where that list lives. And the Python interpreter magically goes to that memory address and gets us the list whenever we try to reference A. All right, so when I passed in A here, I didn't pass it a list. I actually passed it the memory address where that list was. It's passed by reference or passed by address. When I passed do something, the value R, I gave it a copy of the number 2, not the address where you can find the value of R. So 2 got passed in here. It got associated with a variable named C here. I changed it to a 7. And then I printed it out, seeing that C is now 7. C is 7. But once I exited do something, and I came back out here and I went to print out R, the value of R is still 2. The value of R is still 2. See how that works? So pass by reference versus pass by value. Lists are passed by reference. So when we pass a list to a function, or dictionaries, we're going to start talking about dictionaries hopefully today. These guys are passed by reference, which means if a function makes a modification to a list or a dictionary, that list or dictionary will now permanently alter. That makes sense? Now, one last thing to show here. Let's call this do something to a string. Then down here, I'll say blah is equal to hello. Then I'll call do something to a string, passing it my variable blah, and then I'll print out blah. So I have a variable named blah. I set it equal to hello. I passed it to my function. Blah came in here as a variable named s. I immediately changed s to world, and then I printed the changed value. So we expect a world from here. The question is blah world, or is it still hello? We see that it reverted to its own, to its original value. So strings are passed by value. This is pretty common in modern programming languages. It would be easy for us to say all collections are passed by address. But the reality is we would say except strings. In almost all modern programming languages, strings are treated as primitive types as far as variable passing goes. They are passed by value, not by address. So even though we've seen that strings behave a lot like collections, you know, we can spin through every element of a string, forwards, backwards, things like that. They seem to use a lot of the same syntax. If I want to get bucket 3 of a string, I index it the same way as I index a list. So, and I promise you, actually, under the hood, they're implemented as a list of characters. That's how they're written. And if we roll back in time, I actually think I had a piece of sample code open in one of these things that had some old C code in it. So stuff from 1968 they were doing in the operating systems or the systems programming class. Let's be good enough. So in C, strings don't exist. So we actually pass strings as character pointers. You've heard me say the word pointer here a couple times today. What's a pointer? This is a variable type that is capable of holding a memory address. And we're going to see plenty of memory addresses in here once we start working with classes. Unfortunately for us, although I think I can get the idea of my list, but Python tries to make things as easy as possible on the programmer, so things that are common to the language are automatically resolved to their value for us. So even though a list, I'm promising you, a variable for a list actually holds the memory address where that list lives. If we try to print out the list, Python says, I think you probably want me to print out the list itself, not the crazy memory address where that list lives. So it goes ahead and does that extra step for us. Once we start writing our own objects, Python will be like, look, I don't know what it means to print out a dog object. You just invented it. All right, so I'm going to give you the memory address because that's the best I can do in that particular case. And we'll talk about that again when we get to it. But in any programming language, the idea of a pointer, and notice I'm talking about a variable type here. We're working in a loosely typed language with Python, right? We don't define types, but do types still exist? Sure. We've seen all sorts of errors that have told us you can't do concatenation unless there are string types on both sides. You can't do addition unless it's numeric types on both sides. Python very much has types. In fact, it has a whole extra engine that's slowing down our program to deal with types. That type inference engine that figures out what kind of animal we have stored inside of our variable before it lets us do stuff with it. That makes sense? All right, so types exist. Pointers exist in Python. We just don't have a specific syntax for working with them. I go to a strongly typed language like Java, C++, or C. So Java, you guys will start seeing that next semester when we start working in the 250 class. I don't use a textbook in there, a printed textbook either, for the main reason that most printed textbooks say pointers don't exist in Java. Or I could show you the example. Well, you already saw it. right? I wrote 2 lines of code today, and there's a pointer. That's a memory address. All right, hexadecimal number. We've been working with hexadecimal numbers. That's a crazy looking memory address. There's a pointer right there. They exist in Java. Java just does not give us a special syntax for working with them. Either does Python, right? Python, if I print out a list, it shows me the pretty list. It says, look, I know what lists are. I know what lists should look like. This is probably what you mean. Maybe once in a blue moon, when you print out a list, you actually care about the memory address. And there's a function called ID that'll allow you to get at that. But, punchline is, it'll do the heavy lifting for you. Java doesn't even give you that much. Java says, hey, if it's a string, I'm not going to let you get at that memory address. Here's your string, even though they are stored by memory address. An array, same thing. Arrays are lists in Java. So we don't have a way of distinguishing what we want it to do. In an older language like C, this is a language from 1968, we do have a special syntax. So if we were thinking about this in terms of, this is equivalent to a character array called start track, or in Python, it would be start track, where start track is something of the format of like a list. These are all the same kind of animals. All right, so even though this looks more complex, let's say, this is just a list of characters. But in an older language like C, a specific type for a string did not exist. So a string was represented as a collection of characters, a list of characters. And when I passed it to a function, here's a function in C, I said, here is a pointer. So whenever you see an asterisk in C or C++, that's saying this is a variable of type pointer. It's a variable capable of holding a memory address. So this holds the memory address of a character. So I'm passing in the memory address of the very first character in that string. And then I can walk through that from there to get the rest of my string. Bucket 0, bucket 1, bucket 2, bucket 3, so on and so forth. All right, so older languages didn't even have strings. These guys pass strings by address. They don't treat strings as special cases like a lot of our modern languages do, because strings didn't really exist. We could accomplish the idea of strings using character lists. That makes sense? And in Python, lists of characters are passed by address. Strings are passed by value as a convenience for us. And that kind of makes sense if we go back to maybe the rationale for that. Why are strings passed by value as opposed to address? Strings are very common. So we use them like primitive types most of the time. We use them as if they're integers or characters or floating point numbers. We're kind of passing them around as simple variables, even though they're a little bit more powerful than that. All right, so this was a decision made by the programming language creators to say, we're going to treat strings as kind of a special class of citizen. We're not going to treat them as like the other collections. We're going to treat them as something that doesn't get thrown around by address. All right, so this is kind of something to be almost memorized, I guess, but generally speaking, this is a true statement. All collections are passed by address. When we start working with objects, writing our own objects are kind of like our own types of collections. They hold a bunch of name value pairs as well as some functions. Those guys also get passed by address. So this statement is mostly true from a memorization perspective. Anything that's a collection or like a collection will be passed by address, with the one exception of strings. Strings are just special. Okay? So that's why when we wrote this one that made a modification to a string, that modification was not permanent. All right, that makes some sense? Okay, But the big picture thing here where I kind of got started with this. So a lot of good stuff here. I'm going to leave the code in, go back and review this because this is stuff that I would probably put on like your top 5 list of programming knowledge type stuff. You want to be able to predict what happens. I know Python's a little bit ghetto from the perspective of the way they handle their variables when you put everything inside of a single procedural approach, but we'll get past that pretty quickly. I just don't want to show you classes and stuff yet. But in any case, when we pass something into a function, that value is linked to the variable that was defined inside of that function. So in this case, we refer to it as a list, not as the original variable that it was passed in. Those two are no longer directly linked. They are indirectly linked. That make sense? I had several questions about this exact thing today over the weekend. So that's why I wanted to cover it. And Python doesn't make it the most convenient because you can start getting correct. You can start not getting errors, but not getting the result you expected. Make sense? So I think Python's a little inconvenient from that. It's a little fast and loose with its variable scoping. All right. So if you wrote display reverse like this, that's fine. You know, you'll get credit, but I really encourage you to think about it the way we've been writing stuff in class. So I'll write the alternative of this. So we'll call this guy display reverse 2. He'll take in a list. And what we want to do is we want to go through our list backwards, building up a new list. All right, that's the idea. So we're going to remember something. We want to build up a brand new list. So we're going to call this guy answer list. And he's going to start off as a list with nothing in it. Then we're going to walk through our list in reverse. So we have a for loop that can go from the last index of a list to the first index of a list, or the last index of a string to the first index of a string. So that's our for I in range from length of a list minus 1, the last legal bucket, down to, but not including, -1, because we want to include 0, and take a step by size -1. So if we have a list with 5 elements in it, we'll go from 4 to 3 to 2 to 1 to 0. Each time through, we'll say answer list dot append, and we want to append a list at bucket I. And then we'll print out answer list. All right, now, first of all, notice the difference between these two. Let me go back up to our display reverse on A. So I'm going to call this guy, I'm going to go ahead and just create a variable here called B. Since we already know A is being destroyed. And I'll call display reverse 2 on B, which will display B in reverse, but then I'll print out B. So here is A in reverse, and this is calling our original reverse function. This is calling our reverse 2 function, where I built a new list. Then I'm printing out the value of A, and we saw that A changed permanently, correct? Then I'm printing out the value of B. We see that B did not change permanently. So this was B inside of display reverse 2. This is B after display reverse 2. So the question is, why didn't, if I look at display reverse 2, why didn't it permanently change whatever that points to?
It created a new
Yeah, something brand new. I never actually made any changes to A list, did I? I went from the end of A list to the beginning of A list. Each time I just took the value that was in A list and I appended it to answer list. I built up a brand new variable here that was filled up with some of the contents from A list, but I never manipulated A list here. Does that make sense? So A list was passed by reference. It would have shown its changes had there been changes. I just didn't actually make any changes. I built up the reverse version of A list and then printed that, rather than in this first one, the original display reverse, I reversed A list permanently, printed the reversed version, but if I wanted to, how could I undo any damage I had done? Could I modify this code here to undo the reverse? Go ahead.
Could you do like B list is equal to A list dot reverse?
I'm talking about right here, this guy right in here. Just this function. So, oh, okay. So you want a variable. You want to say B list is equal to what?
A list dot reverse.
Okay. So
And print B list.
we're not going to print it because we want to we want to undo the damage that we had done external to this guy. We already saw that the reverse function earlier when I was first using it actually returns a value of none. This guy doesn't return a value. He just permanently changes this. So really it would just be this. That'll undo it. Reverse it, print it, reverse it again. If I reverse something twice, I'm right back to the original order, right? So maybe a little bit of an inefficient way of accomplishing that, but
What would happen if you did like after all that A list equals? That would change it again, right? To
where do you want me to put that?
after reverse.
Like here?
Yeah, and then and then define it again. I mean.
Oh, so like say A list is equal to 1, 2.
Yeah.
That would actually give us it would not break it. Because this is a brand new memory address, a brand new list.
Yeah.
So we see that that A list is back to elephant, dog, cat, the reverse of it originally. Yeah, it's a good question actually. So he's saying, oh, well, I came in here and I redefined A list. So what you actually did in that case, if we're drawing the picture, I actually created a new variable, a new value in memory. I just made A list point to him. That did not break the value of A. Yeah, but that's a really good question because that's somewhere where you would get stumbled. Okay, drawing the picture here is what actually shows us the result of that. I didn't change the contents of the value A list points to. I changed what A list points to. By setting A list equal to something else, I updated what it points to, as opposed to changing what it points to, changing the value that it points to. Okay, so this guy would undo the thing. So if I reverse it once, then print it, then reverse it again, I've undone my reverse. What he was suggesting is do something like B list is equal to this. The B list is not necessary. This won't break. This would just set B list equal to none. A list has already been permanently reversed. We didn't need to temporarily store it somewhere or anything like that. All right, so in your homework, if you wrote it with this reverse thing, nothing in the assignment said you had to leave the original list unharmed. So you didn't have to do this A list reverse thing if you didn't want to. I'm not going to take off for it, but my intended version of this answer was this guy, where you walk backwards. Notice the last several classes we've been writing loops that go backwards. Build up something brand new, and then print, or, well, in this case it was called display, so print out that new version of our list in reverse. That make sense? Okay, so make sure you take a peek at general chat for the hackathon information for the future ones, and hopefully save the date for it. I think everybody who went to it had a good time. Maybe talk to them as well. It definitely is not a waste of time. It is a long day, but you learn a lot during that day. Anyways, I will see everybody on Wednesday.